All right, so now for the back page. So, well, just like all the previous graphs, we had we asked you to draw graphs based on the equation. So now we turn around and we say, hey, guys, if we give you the equation, if you give you the graph, can you write the equation down? So the way you get the equation, it's really just a complete walk back to the equation. So you're shown this graph. It could be a secant graph. It could be a cosecant graph. It's just like before the break. You could be shown a sine graph or cosine graph. So the way we tell the equation here is that let's go ahead and identify a few things. And let's go ahead and draw the actual wave, the sine graph or cosine graph. So first, let's identify these points right here. So we know for sure that the sine graph or cosine graph would have these points. So let's go ahead and put 2 dots there. And the other thing we also want to find out is that where's the midline in this case? Where's the midline? The x-axis or 0. So we can tell that our d value is actually 0. So that's nice. Okay. So that's our midline right here. And since we know our midline, that means we can also tell the zeros. The zeros happen at the asymptotes. So yesterday we were like, oh yeah, if you look at the sine and cosine graph, if it hits the midline, then you draw the vertical asymptote. And now we say, oh, you look at the vertical asymptote, so you can draw the points that hits the midline. And then you can just go ahead and connect the dots. And let's take a moment, give you 30 seconds to write down the amplitude and period. And then find out the A and B values, right? 30 seconds. What's the amplitude for the sine graph or cosine graph right there? And what is the period? And then find the B value accordingly. The amplitude is 3. So the A value is 3. The period, that's one complete pattern from negative pi to 3 pi. That means the period is 4 pi. And B value would be 1/2. Okay, so we know D value already. And now, so we have all these information. So now here's another question. Now you could do sine graph or cosine graph in this case. Which one's easier? Right now, if you do a sine graph, then you have to make sure that you include the phase shift, which is shifting to the left for pi units. You can do that with a sine graph. So if you do that, so let me use a lighter color. So you would be writing down 3 times sine, and then 1/2, and then x plus pi. All right, you will have this. If you do this, if you use a sine graph, then your official function will be y equals to 3 times cosecant 1/2 x plus pi. That's your official one. Okay, just like how we did before, the last 2 days, we saw the cosecant function. We quickly write down the sine function, and we use a very light color to plot the dots for the sine function. Now we basically do the exact reverse direction. Okay, so if you do sine, then make sure you include the phase shift. Now, you may actually consider using a cosine function because it starts at the highest point. Well, that's exactly what cosine does. Starts at the highest point on the y-axis. So if you do cosine function, which I would strongly encourage you to write it down as well, then you just do this. 3 cosine of 1/2 x. Done. And therefore, the official equation would be y equals to 3 secant of 1/2 x. So now if you have to choose again, would you choose sine or cosine? Yeah, I would choose cosine. Okay, just having fewer things to write down, less chance to make a mistake. Okay, so any question about how to write these, obtain these numbers? How to go from a given graph, and then you have to draw the sine graph or cosine graph so that you can obtain all these features. Like there's no way to obtain these features by, I mean, you can still obtain the 4 pi, but the amplitude 3, it's a lot better to write down to draw the sine graph and cosine graph to get it in front of you. Okay, so now again, we don't have theta. Let's go ahead and overwrite the theta with the letter x. So, and go ahead and answer these 2 questions. Okay, as x goes to pi from the left. Now we are talking about the actual graph that's printed. So let me go ahead and erase this yellow line right here. Okay, so we're talking about the actual graph that's printed on paper. As x approaches to pi from the left, the function's going to where? And then as x goes to pi from the right, the function it's going to where? Okay, as x approaches to pi from the left, it goes to everyone, infinity. And x approaches to pi from the right, it goes to negative infinity. Okay. Next up. Right now, what kind of function is this? Is it a tangent or cotangent function? It's a cotangent function because it is a decreasing function. All right, now, so that means we will need to get the tangent function, get the useful values, and then we can write down the equation. So now, can you tell where the midline is? The midline, it's what value? Negative 0.5. Okay, so negative 1/2. So that's your d value. Okay, so the entire graph is being shifted down. Now, I think my primary worry is this. My primary worry is that how focused are you in writing all these values and thinking about these graphs? Like thinking about where's the midline, where's the vertical asymptote. Okay, so in this case, when you see the points right here, they share the same points, but the asymptotes will become the points on the midline, and the points on the midline would become the asymptotes. So if I have to recreate the tangent graph, I'm just going to create one set right here. I'll go ahead and create one set right here in the middle. So now, go ahead, give yourself 30 seconds. See how many A, B, C, D, well, we've got the D values. See if you can get the A, B, and C values here. Okay, so we got a D value. We got the D value shifted down. And for tangent graph, well, I mean, supposedly we will start at the origin. So we shift it down, and here we also shift it left. That means we know the C value, it's, where's the C value? Negative pi over 4. Okay, negative pi over 4. And negative pi over 4. And then we also have, do we have an A value? Well, for a typical tangent function, we go up, well, we'll plot the point at 1 unit from the midpoint, midline. But now it's just only, whoops, half a unit. So A, it's 1/2. You go from 1/2 to 0, 1/2 to negative 1/2 to negative 1. So the A value, it's only 1/2. And what about the period? Looking at the period, we have from, what is it? This is a negative, wait, hold on. This is pi over negative pi over 2. So this is negative 3 pi over 4. And this is pi over 2. So pi over 4. So the period, it's a pi. That means the B value, it's equal to 1. So now you can write your tangent equation, which is 1/2 times tangent of x plus pi over 4, because x minus negative pi over 4, minus 1/2. That's your tangent equation. And now you can write your cotangent equation, which is y equals to 1/2 cotangent x plus pi over 4 minus 1/2. Now, if you feel that, come on, it's so tedious, I feel you. I feel exactly the same thing too. This is not my favorite topic. And as I said earlier this week, the good news is that this won't stay here for long. After today, and you have a little review on Schoology, we say goodbye to this. Next week, we don't see this. So the next time you see this again will be on the test. And then you pretty much say goodbye to this forever. So that's the good news. Okay, so if you feel a little bit tedious, yes, I can totally feel your pain. I too do not like this. And it's not really that something that we see all the time. So it's more of an exposure thing. Okay. And so now, oh, forgot this. I should have you answer these two questions before, because now the graph is kind of messy. So just look at the black line that it's printed on the graph. So maybe just look at the graph that I have here then. So as x goes to 3 pi over 4 from the left, as it goes to 3 pi over 4 from the left, it's heading to negative infinity, great. And then if it's heading to 3 pi over 4 from the right, it goes to positive infinity. Okay. All right, so you can go home and try this one. This one is pretty straightforward. It's just a regular tangent graph. We will talk about these two. Okay, we'll talk about these two next week, next Monday. Okay.